So Furnace Creek is located actually in California, and it flows into Death Valley. And it's not so much of interest right now for our story about Furnace Creek per se, as opposed to looking at it as an example of scientific process. Conceptual model is postulated with limited data. Additional data is gathered, ruins the said conceptual model, and you have to keep on iterating. More stories, more data, and how things get refined with time. The interesting aspect of Furnace Creek, or the most noticeable, is groundwater discharge, coming from springs, diversions, rhyophytes. The key aspect is that estimated discharges have ranged between 4,000 and 6,000 acre-feet per year. Regardless of which number you want to pick, this is way more flow than any potential recharge in the catchment. Plus, water chemistry of the spring shows some of the water is coming from the spring mountains and the Ash Meadows groundwater basin, quite some miles away. Now, as we looking at Furnace Creek, let's back out a little bit and take a look at the scale of the catchment. You'll see that at 150,000 acres encompassing Funeral Mountains to the north, Greenwater Range and Black Mountains to the south, you have something where there's next to no rainfall, with a max of 0.6 of a foot per year and averaging 0.3 feet a year. That is nothing. So therefore, the local recharge that can be generated is also negligible. Using Maxi-Econ style estimates, you're looking at 300 acre-feet or less. So obviously, more water is needed to supply the springs at Furnace Creek. Hunt and Robinson, back in 1960, considered this dilemma of where does the extra water come from, and they wound up postulating that water could move from Pahrump Valley along the Furnace Creek fault zone to discharge at Furnace Creek. And a large part of what drove them was the similarity in water chemistry between Ash Meadows and Furnace Creek Springs. Of course, they were also thinking about other work and knowledge of what's occurring in the area, knowing that Ash Meadows discharged about 17,000 acre-feet, 7,000 acre-feet was the estimate for Franklin Lake, and only 4,000 down at Furnace Creek. The work of Walker and Econ accounted for the water discharging to Ash Meadows and Franklin Lake, and conceptually at the time, you're picturing the Funeral Mountains as more of this barrier. So therefore, the only place we're left to get water from is from Pahrump. More than a decade later, Winograd and Thornton revisit all this, and they wind up rejecting Pahrump. And much of the work from Winograd and Thornton was explicitly putting together and mapping the geology and saying, what can it tell me about the hydrology? And the main reason for rejecting is primarily because there's a very thick clastic section between Pahrump and the Amargosa Desert area. So in this case, you're cutting off the flow, you're not likely to have as much. In addition, they looked at the geochemistry of the area. And the geochemistry says that, okay, the water in Pahrump Basin differs from what we see at Furnace Creek. And as far as putting things together and saying, well, where does the water come from? Geochemically, they say, well, I can explain the water coming from the central Amargosa Desert. Of course, we're back to the conceptual problem before saying, well, what about the Funeral Mountains? But we know they're comprised of carbonate. We know that it can be transmissive. And the gradients are such that, yes, water can flow downhill towards it. So in which case they're saying, okay, here's an explanation for how the water gets from central Amargosa Desert to Furnace Creek. So while Winograd and Thornton were able to explain water moving from central Amargosa Desert to Furnace Creek, they stopped short on the remainder of the explanation of explaining the quantity of water necessary to come from Ash Meadows Basin over to the central Amargosa Desert. So they were familiar with Walker and Econ's work. They were familiar with the fact that there's this funny upwelling, odd-looking contour around well 84. And they were familiar that the geochemistry around well 84 and Ash Meadows are similar. Although when they looked at it and talked about this potential for flow necessary, they said, well, probably not, because they also said, it looks like you have a thick clastic wedge. Yes, there has to be some flow, but not so much. It has to be limited to some degree. Clausen revisited this area in 1985, and primarily to explain more geochemistry in the central Amargosa Desert. But in looking at it, he's saying, well, you've got this high, and maybe I can't say as much about what's going on the carbonate side to the east, but I have a lot of information about what's going on in the central Amargosa Desert itself. We have lots of wells drilled. I have specific capacities. I know about the gravel or clay content. And so I've just shown you the mapped area where it has a high degree of sand and gravel in it. So, okay, it's possible to move the water. In addition to when I wind up looking at the specific capacities around it, okay, yes, I can explain all this water coming in and moving through this well 84 corridor. After Clausen's study, a couple of oil and gas wells were drilled. The one just highlighted, well Felderhof Federal 5-1, it encountered carbonate rocks at about 850 feet below land surface. By 1,400 feet below land surface, voids and losses were encountered. Drilling had to stop because it could not maintain circulation. Static water level in this hole, 2354 feet above sea level, which was about what you would expect in the carbonate. And you have these transmissive carbonate rocks. So it doesn't prove it, but it does support the idea that, yes, water could be moving between basins in the well 84 corridor. So as we go into the 90s, we wind up having these regional flow models being developed, mostly to explain radionuclide transport, but also the effects of pumping and groundwater development. And we need to wind up filling in this space, so therefore we wind up needing to keeping track of our conceptual models. So for these studies, the Furnace Creek fault story wound up being modified. So instead of coming from Pahrump, now it comes from more like the test site through Ash Meadows and underneath the basin fill. Looking at this in section, you can kind of see what the flow pattern would be, moving the water from the test site area, most of it discharging around Ash Meadows, with some making it into the basin fill down to Furnace Creek. This winds up being the preferred story for the UGTA regional model published in 1997, the first USGS Death Valley flow models in 2004, and the other Death Valley flow model from the USGS in 2017. Now, when we look at the UGTA regional model that was published in 1997, one of the key things to note is that there was more water coming out of Franklin Lake. We went up from 7,000 acre feet per year to 10,000 acre feet per year based on a study by Zarnecki and Standard. And if it's really discharging this much water, that implies that you've got to have some transmissive connections around it in order to get water out of the ground and have it move. That winds up being a serious part of the interpretation. When we put the rest of the things together, the Furnace Creek fault zone is interpreted as a conduit that can potentially move water from the Ash Meadows area over towards Furnace Creek. And this was based and stated for this model. Of course, the simulated results don't quite agree with the conceptual model, with most of the water from Ash Meadows running and discharging at Franklin Lake, and Furnace Creek being supplied from Yucca Mountain area. It was also recognized in the 90s that our knowledge of groundwater discharge could be improved. So studies were put out in order to sit there and better measure the discharges by putting out micrometeorological instruments to measure rates, and then also mapping out ET areas in order to integrate and get an better idea of groundwater discharges throughout the region. From this work, the discharge from Ash Meadows itself remained about the same. But revisiting Franklin Lake, the amount of discharge went from 10,000 acre feet to less than 1,000 acre feet per year. Estimates for Furnace Creek wind up being about 6,000 acre-feet a year. A slight, but very slight increase, but a very minor change. Also, work from DeMayo suggests that you might have another 2,000 acre-feet discharging off the floor of Death Valley. Both this discharge off the floor of Death Valley and the shrinkage of discharge from Franklin Lake would suggest that you have little to no flow along the Furnace Creek Fault. Now, the Death Valley flow models, versions 1 and 2, published by the USGS, their conceptual model of water making its way to Furnace Creek is again along this deep carbonate flow path. Now, the good part about having a flow model is that one can go out and test it out. You can backtrack your past and find out, well, what is the model simulating? So in this case, we go to Furnace Creek, we assign particles, and we backtrack them. And we find that for Death Valley 1, we have actually water coming from beyond the model to the north somewhere, and Paiute Mesa and also AFFCR basins. And wind up in version 2, okay, it doesn't head as far north, but we have water coming from Paiute Mesa and AFFCR basin. In both cases, though, not a drop of water comes from the Ash Meadows groundwater basin. So at this point, the proposed conceptual model and numerical models, they have inconsistencies. They don't agree. We should be looking for another model now. So another conceptual model would be to say, okay, basin fill winds up connecting carbonate rocks in the Funeral Mountains and the Ash Meadows groundwater basin. If we tilted this, look at it in section, we can go through and say, okay, water comes along from Ash Meadows area, enters the well 84 corridor, moves through the basin fill into the Funeral Range, and then winds up discharging out Furnace Creek. In this case, it hasn't quite been postulated like this before, but it's really nothing new. The connection through the Funeral Range was postulated by Winter and Thordson in 1975, and flow up through the 84 corridor was put forth by Clausen back in 85. In addition to the fact we know that the chemistry, at least from carbonate to 84, is consistent and makes sense. Well, what are some of the things we know that can support the idea of water being connected from the carbonate in Ash Meadows to the carbonate and Funeral Range by flowing through the 84 corridor, which has been estimated to move about 80% of the interbasin flow. Well, one of the things is in well 84A, it exhibits earthquake responses, which is unusual because it's completed in basin fill. This is more typical of a carbonate well. Also, water level declines in wells 84 and 84A have been muted to less than 1/10 of a foot per year, whereas those wells just a few miles further to the west declining at rates of almost 1/2 a foot a year in response to pumping in the central Amargosa Desert. So this corridor winds up being well defined by both water levels and specific capacities in the basin fill. So Halford and Jackson wound up characterizing regional groundwater flow, in this case, the basin fill flow path winds up being adopted as the primary conduit for connecting things. And these concepts are tested by building a numerical model where calibration considers the well 84 corridor and not just simply numerically in the objective function, but qualitatively or replicating the shapes of the water level profiles that have been observed in reality with the groundwater flow model. And of course, the same method of testing of, well, does it make any sense whatsoever, can also be applied to this numerical model, where you wind up backtracking and finding out where did the water come from. In which case, okay, the water is coming through the 84 corridor, and it's about the right mixture to explain what we think it should be. These are promising results. At least it's not obviously wrong. Doesn't necessarily mean it's right, but it is worth investigating further. And those sort of things might be an aquifer test around well 84, pumping the carbonate, or better characterizing what is the actual discharge at Furnace Creek. So in conclusion, regional flow, your interpretation of it is profoundly affected by your groundwater discharge estimates. Having something like Franklin Lake go from 10,000 acre feet to 1,000, less than 1,000 acre feet, makes a big difference in what you picture and how you think about it. So as you revise your groundwater discharge estimates, the conceptual models for how water moves around also has to be revisited and re-examined. Qualitative results are also significant. When talking about the 84 corridor, the water levels, while from the point of view of absolute head differences aren't very huge, they do form a distinctive shape that you have to replicate those shapes in order to say that, yes, I'm simulating this feature correctly. And with our numerical models, we wind up testing our conceptual models. We might put forth an idea, but when the numerical model and conceptual model disagrees, it's time to revisit it. Either get rid of the numerical model, conceptual model, or both. And if we do have agreement, doesn't necessarily mean it's right, but we definitely want to test the implications and find out, how does this work? Does it make sense?